Probably say all that stuff again. So today's Monday, March 27th. Next test is next Thursday. We do have block day this week, but not block day next week. And it's fill in the blank notes, so that those will be posted if you don't already have them. 2 days on parametrics, which is completely new, but also not difficult. And then a bunch of days on polar, which is kind of new and a little bit more difficult. So it's a different unit than most of the previous ones, just because it is very new. All right, up to this point, you've been representing a graph by a single equation involving two variables, such as x and y. And you're like, yes, that's all we've ever done, is y equals some function of x. X squared, sine of x, 2x minus 3, whatever. Like, it's always been y equals something with x. In this section, you will study situations in which it is useful to introduce a third variable to represent a curve in the plane. We normally let this variable be t, and it is convenient to think of t as time. Okay, so you're going to have a pair of equations. One tells you what x is doing, and the other equation tells you what y is doing. And so you don't initially have y in terms of x. You have x in terms of t and y in terms of t. So as t traces out some values, kind of jump into this table down here. As t traces out some values, you plug in t to x to get the x coordinate, you plug in t to y to get the y coordinate, and then you graph the x and y. I mean, I guess just like always, you graph x comma y. It's just an extra step to get there, because you have to plug in t to x and plug in t to y, and so it's weird, it's different, it's new, but again, I don't think it's that difficult. So let's complete the table. X of t, they tell us, is t squared minus 4. And y of t is 2 minus t. So at least initially, it's sort of like when you're first learning to graph anything, you just make the table of values, right? You don't really understand what's going on yet, but you just plug in, get some points, put the points on the graph. Same thing here. So if I plug in negative 3 for t, square it, I get 9. 9 minus 4 is 5. If I plug in negative 2 to t, negative 2 squared is 4. 4 minus 4 is 0. If I plug in negative 1, 1 squared minus 4 is negative 3. And I'm going to, you know what, I want to leave you to fill some of these in. Let's jump over to the y column and do a couple of those together. So 2 minus negative 3 would be 5. 2 minus negative 2 would be 4. 2 minus negative 1 would be 3. And I'm going to press pause and let you finish filling out. The y table had a nice, easily identifiable pattern. The x table, maybe not so much. And then we take those points and we'll plot them. Now, plotting them works just like always. You sort of ignore the t when it comes to the plot, because this graph over here is an x-y graph. So I'll plot the x and the y. Okay, so be careful. You use t to come up with x and y, but then when you go to the graph, you don't use t anymore. You only use x and y. So 5, 5, 0, 4, and so on. So this sort of looks like a parabola. All right, well, what's new and different, in addition to just how to come up with the points, is that curve now has a direction, right? Because we started, it had a specific starting point, was up here, and then we went to the next point, and to the next point, and so on. And so your graph is incomplete until you have the arrows on there. So that's new to graphing, right? Graphing x, y, that's old news. But putting arrows on there because it has a direction, that's a little bit different. Part C, find the rectangular equation. Oh, let me back up a second. It told us to only go from -3 to 3. So even though when we usually graph, we would like just sort of extend out the parabola, we don't want to do that here. We're only going between -3 and 3. So it has arrows to indicate direction, but it does not have arrows to indicate that it continues. So be careful. Find the rectangular equation. That means y as some function of x, meaning get rid of t. So let's solve one of them for t. In fact, to make it easier, let's solve x for t. We'll always do that. Or solve x for t. So take your x equation and solve it for t. So let's move the 4 over. And then square root both sides. Although something is going on that I intentionally forgot there. Plus or minus. You put the square roots on, you get the plus or minus. And then we'll substitute that in to the y equation. Thank you. So we found what t is equal to. So we'll use that in the y equation. Y equals 2 minus plus or minus square root x plus 4. And you can leave it like that. If you don't like the plus or minus, you can write it separately. So 2 minus the positive one would be 2 minus square root x plus 4. 2 minus the negative one would be 2 plus square root x plus 4. So I'm fine either way. Obviously the easier way is to just leave it as the plus or minus. If you were going to put this in the calculator, you can't put plus or minus in the calculator. You would have to put the two different pieces in there. All right, why don't you try 2a and b? We'll get to c together in a minute, but you try a and b. So plug in -4 into x and y, -3 into x and y, get the table of values, and plot the graph. Okay, so there's the table. Okay with that? Again, the t's looked weird initially, but then when you go to plug them into x, you see why those t's were picked, because it made nice integers, nice answers for the x's. So 0, 6, 1, 5, 2, 2, 3, 3, and 4, 10. Okay, I kind of don't like this. I don't like the table they gave, because you missed something important. Let's put t equals 3 on here, because that's going to be an important value, and you'll see why in a minute. It doesn't work nice for x. Square root of 6. What two integers is the square root of 6 between? You can at least give me that much. What two integers is the square root of 6 between? 2 and 3. So for our purposes, yeah, it's 2 point something. I don't know what the something is, but that'll be good enough for this graph. And then here's why I wanted to include 3. If I plug in 3, what's my y value going to be? 0. So that gives me another point at 2 point something, comma 0. And that's where this graph sort of bounces back the other direction. And again, put some arrows on there to indicate the direction. Part C, find the rectangular equation. That means the y and x equation by eliminating t. And you almost always, I can't think of a time you don't want to. Start with the x equation, solve for t, plug that in the y equation. So square both sides, move things around a little bit, and then x squared minus 3 goes in for t in the y equation. So y equals absolute value x squared minus 3 minus 3. So absolute value x squared minus 6. We'll do one more example, but again, these aren't, it's not that they're hard, but it is that they're new. We've not really done this kind of 3 variable stuff before. So slow down, take it slow, be careful, but I don't think it's difficult. Most of the time, students do fine on this part of the test. All right, one more, just because some of you wanted to see sines and cosines. You didn't want to go a day without experiencing that, so I wanted to provide that opportunity for you. Consider the curve in the xy plane given by x equals 4 sine t and y equals 2 cosine t. Complete the table below, but here's some values that might be helpful. So I'm guessing these will show up somewhere. I guess let's just do all the signs first. So 4 sine of 0 be 0, because the sine of 0 is 0. In fact, actually I'm going to clean this up a little bit. 4 times sine of pi over 6. Let's go popsicle sticks here for our unit circle values, because everybody knows those really well. Right, Joseph? What's the sine of pi over 6? 1/2. So 4 times 1/2 is 2. And then 4 sine pi over 4. Audrey, what's the sine of pi over 4? 2 over 2. So that becomes 2 root 2, which they conveniently gave to us over here. Right, the 4 and the 2 reduce, 2 root 2. I'm not going to write all of those, because when it comes to graphing, there's no way to write, there's no way to accurately graph 2.828. Like 2.8 is going to be as good as it gets when it comes to graphing. Let's load up all of these here.
So you don't multiply them?
I did multiply them. 4 over 2 becomes 2.
Oh.
And then 2 root 2 is 2.828. Cole, 4 sine pi over 3. So what's the sine of pi over 3? Root 3 over 2. So again, the 4 and 2 reduce to 2. That gives me 2 root 3, which they tell me was 3.5. Again, I don't need all those decimals when it comes to graphing. There's no way I could be that accurate anyway. Gregory, how about the sine of pi over 2? Sine of pi over 2? 1. So that's an easy one. Brandon, how about the sine of 2 pi over 3? See, 2 pi over 3 would be like right there. Sine means the y coordinate of that spot. The y coordinate is the long side. How long is the long side on the unit circle? Here's a hint. It's the same thing as the sine of pi over 3. got to be root 3 over 2. So that becomes 2 root 3, which we already said was 3.5. 4 sine 5 pi over 6. Jake, what's the sine of 5 pi over 6? Yes, it is 1/2. Okay. I don't know. My brain needs to see the picture before I get it right. Luke, how about the sine of pi? 0. Blow through all the popsicle sticks today on the unit circle. JD, how about the sine of 5 pi over 4?
Negative square root 0 over 6.
Yes. So they told us that 2 root 2 is 2.8, so this would be negative 2.8. Derek, how about the sine of 3 pi over 2? Negative 1. Angel, the sine of 7 pi over 4?
Square root 2 over 2.
Positive or negative? It's the y coordinate, so it needs to be negative. And then Ava, the sine of 2 pi? 0. So, that's a lot of work just to get the x coordinates. Now we get to do the same thing for the y coordinates. 2 times cosine of all those things. Trying to be more efficient here and just write out the 2 parentheses to start with. And then I need to find the cosine of all those values. So I'm going to hit pause and give. So there's all the values for cosine. So 0, 2, 1.7, 2.8, 1.4, 3.5, comma 1, 4, 0. Which is sort of my first quadrant or first fourth. 3.5, negative 1, 2, negative 1.7, 0, negative 2, negative 2.8, negative 1.4. Some of these are kind of tricky to locate. Negative 4, 0. Can you tell with that many points what shape that traces out? What's that? An oval? You remember the more official name for an oval? I mean, you're not wrong, but an ellipse would be a more mathy name for that shape. Now, what's wrong with that graph? You know what's wrong with that graph? No arrows. I got to put the arrows on to indicate a direction. So there's no set number. This one looks like 1 per quadrant, makes a nice. But I guess technically if you just put 1 arrow on, you'd follow it around and that'd be enough. But usually we put 2 or 3 on there to just to kind of help show what's going on.
How do you decide the direction?
Okay, so that's a good question. How do you decide the direction? You have to remember what order you put the points in. The time decides the direction. So we started with that point, and then we started working our way around. So you have to remember what order you put the points in on. And so that's another way of saying the difference between these and just XY graphs is there's an order to it, and you have to recognize that order and indicate that order with the arrows. All right, last one. This one's a little bit different here. Find the rectangular equation by eliminating the parameter. Alright, x equals 4 sine t, y equals 2 cosine t. I don't really want to solve this for t, because then I would have x over 4, the inverse sine of x over 4. Like, this is going to be a mess. So there's a trick to this one. If sine and cosine show up, do you remember an equation that has sine and cosine in it that's always true? Sine squared plus cosine squared equals 1. Okay, so this is definitely different, because like, where did that come from, except that you have to have done one of these problems before and recognize sine and cosine. So let's get sine squared. So that would be, let's see, if I divide both sides by 4, x over 4 is sine. So in for sine goes x over 4, and we square that. Y over 2 would go in for cosine. And then if we squared all of those, x squared over 16 plus y squared over 4 equals 1. Do you remember what shape that would trace out if you graphed it? Of a hint, we just graphed the shape. It's an ellipse with center at 0, 0, and remember this, sort of an x radius equals 4, and a y radius equals 2. Radius isn't exactly the right term because you're not doing it in all the directions, but you'd go left and right 4 and up and down 2. Do you remember that from graphing ellipses long ago? It's like, oh, yeah, kinda. X radius, sorry. And Y radius. So you look back at our picture, and yeah, that's centered at 0, 0. We went left and right 4 and up and down 2. So we transformed this from a parametric equation into an XY equation. All right, today's assignment is worksheet 1, and I will pass that out.